Hello everyone, today I am going to explain an important concept from engineering thermodynamics called the adiabatic process. It is very useful concept for understanding how gases behaves during compression and expansion. An adiabatic process is a thermodynamic process in which there is no heat transfer between the system and its surrounding. Therefore, the heat transfer Q is equal to 0. This can happen when a system is well insulated or when the process occurs very quickly. Here we can see gas inside an insulated piston cylinder arrangement. The insulation prevents heat from entering and leaving the system. When the piston moves, the gas can expand or compress and its energy changes because of work. Now let's look at adiabatic expansion. The piston moves upward and the gas occupies a larger volume. The gas does works on the surroundings since no heat enters the gas. This work comes from its internal energy. As a result, the internal energy decreases and temperature also decreases. Therefore, during expansion, volume increases and temperature decreases. The gas loses energy while doing work. Now consider adiabatic compression. The piston moves downward and compresses the gas into a smaller volume. Work is done on gas, which increases its internal energy. Since no heat leaves the system, the temperature of the gas increases. Therefore, during compression, volume decreases and temperature increases. Here we can see the pressure volume or PV diagram for an adiabatic process. For a reversible adiabatic process involving an ideal gas, the important equation is PV to the power gamma equals constant. Here gamma is the ratio of specific heat at a constant pressure at a constant volume. Adiabatic processes are very important in engineering applications. They are approximately used in air compressor, gas turbines, internal combustion engines, and aircraft engines. They are especially important when compression or expansion happens rapidly. To summarize, an adiabatic process has Q equals to 0. Expansion generally causes cooling while compression causes heating. For a reversible ideal gas, PV to the power gamma is constant.